Hello. So today we're going to be going over a few more um, prompt techniques for software development. And this is what I call controlled versus uncontrolled generative prompts. And basically, the simplest way to put it is when requesting code for an LLM, you can be either descriptive or non-descriptive. However, I like to use this language of control because it's really about capturing this notion of, oh, are you imposing a design scheme on the system's outputs? So just calling it a descriptive prompt isn't very informative. So let's go over an uncontrolled prompt first. So what do I mean by that? It's basically just a prompt that does not impose requirements, does not impose constraints. It basically leaves it up to the AI to decide how to do it. It doesn't reduce the degrees of freedom on the model's output. So this is, best for really simple tasks that don't really require any architecture. Um, they're high degree freedom. They're not very programmatic, and you're really sort of leaving it up to the model. There's a chance that it will make something up more. Um, and there's some benefits to this if you're in a rush. It doesn't take much effort. You just have to ask for something. You don't need to know what you're asking for. You don't have to actually do much work. So it's flexible, it's fast. However, the drawbacks kind of outweigh, specifically in a engineering software development context. This is, you're basically relying on luck. There's no direction. You're not imposing a design on the system. So all of what you're requesting is not going to follow an architecture. You're just going to get what you get and hope for the best. And by introducing these sort of unsystematic outputs into a design system, what's supposed to be a design system, it's kind of a recipe for things not going very well. And you're just going to lack consistency and organization if you just leave it up to the model capriciously to decide. So better to go for a controlled prompt. And a controlled prompt is basically the opposite. You're requesting a solution with constraints and specifications. You're lowering the degrees of freedom. This is necessary for a more complex project that requires more consistency. This is more programmatic. This is more thinking like a programmer, thinking like a software architect. And you're lowering the opportunity for hallucination, or at very least you're providing such clear guidelines that you can easily detect hallucination because you have a list of requirements that you're specifying, and it's either going to meet them or not. So nothing gets by your net. So yeah, the benefits here. Intentional. You have a scheme in mind. You have a structure that you're imposing. Clear evaluation criteria. Pass, fail, self-defined, self-provided. You specify. Faster, if you know what you want and you're looking for something, maybe it's something you've already done before. This is a good way to whip things up, while still having, you might have a grab bag of prepared prompts. this really enforces that kind of engineering mindset. You're systematic. You're having this sort of top-down approach. You're vetting the outputs. You're making it work for you, you know. So really, this is kind of like writing pseudocode. Sorry, I keep doing that. You're kind of just writing the pseudocode, and then it fills in the implementations, and then, you know, you can even go one level deep. But at that point, you might as well just write the program. So yeah, there are some drawbacks to this approach. It does require you to actually know what you want. So you can't just like kind of leave it up to, oh geez, you know, help me out here. I don't know what I'm doing. You know, it's more effort because you're actually, you know, doing work. But at least you still have a job, you know. It can also just be frustrating. There's a point where it's just like, you know, if you want something done right, do it yourself. Stop trying to just find the right words, you know. Stop trying to escape doing some coding and just do it, you know. And there's a certain level of detail and fidelity that you just can't reach with natural language descriptions of programs. So that's more or less it. This is kind of a bite-sized little video. You know, you want this control language. You want to think in terms of control, not just in terms of descriptiveness, because you really want to kind of lasso what the model's doing, keeping it within these boundaries. And you know, I think there's honestly room for more complexity here, where you can have like a controlled element of a prompt and then an uncontrolled element, so that you're sort of leaving it open to be a bit more generative in some areas and more predictable in others. But let's not get too far ahead of ourselves. So let's just do a quick demo here. Here's a uncontrolled prompt. I'm going to put this in. It's not biasing anything, so I'm just going to ask. So there you go. Whatever, you know, cool. Now, I'm going to ask for a more detailed, controlled prompt. And it's sort of in a haiku form here. I put it that way so that it's readable. And now look at what I'm getting here. The output is much more. Not only am I getting what I want, although I still haven't vetted it, so you know, don't. But it's also doing this little extra. Look, I pointed out what I'm doing. So, you know, compare these two. You know, you got whatever. But now you actually have, like, look, a detailed specification. And you're going to want to build an application out of building blocks like this more often than not. Ones that you've thought out every step, rather than one where you're just leaving open these sort of, oh, well, maybe it'll do something, you know. In this case, it's, you know, it's just using a native Python, you know, it's probably fine in this case, but simple examples. Anyways, yeah, that's it.